This is a pretty short set of videos for this section. It's not the longest section. It's one where you're better served really working on examples for yourself. But anyway, the last thing we're going to see here is looking at the number of subsets, where we're going to try and figure out is a way to describe how many sets should be contained within a given set. If we want to figure out that type of thing, it's a good idea to start with something like an inductive line of thinking. So let's start out by thinking about some cases. Start with the easiest case. For the empty set, the null set that we talked about before, well, let's remember what's in there. I want to draw this in roster notation. We've got a curly brace and a curly brace with nothing in it. That is to say, if you want to talk about it a different way, cardinal number of the empty set is 0. Well, that's not a very good start. Use that. What could possibly be in there? Well, when we're talking about subsets, we technically leave equality as an option, provided we're not specifying that they be proper. So, technically, because the empty set equals the empty set is in the empty set. So, we have a single subset. Not a great start, but at least we know you got something. Okay, so we've got something for nothing. Let's see what happens if we can get anything for just 1. Let's say we have 1 element. I'll call that 1 element A. Give it a name. Well, we're going to draw that out in roster notation. That's just A inside of curly braces. And we've got a cardinal number, a cardinality. So the cardinality of the set containing just A is 1. A little bit better than the other guy was. Well, technically anything contains nothing, so got the empty set. That's an important property in here. When we talk about subsets, it's a trivial case, but the empty set is always contained in every set. The only one that it's not is if you want to talk about proper containment with itself. But anything has to have the empty set, so everybody's got one subset no matter what it is. And then we play the same trick we did up here, where we say, well, that has to contain itself at the very least. But unfortunately, we really don't have anything else to work with. So our 1 element set only has 2 subsets. But it's more. Now it went up by a lot. 1 to 2 is a great difference. It's not that big if you're looking at other numbers, but just in that context, we're making progress. Okay, so let's try 2 elements. A 2 element subset, or 2 element set, excuse me. A, B, again, I'll talk about cardinalities. Cardinal number of the 2 element subset is, for obvious reasons, 2. Okay, so now we want to figure out what's in here. Well, we've got the basics. Nothing is in there, and everything is in there. keeping good notes. Hopefully by the end of this, you'll be able to write decent curly braces. It takes practice. All right, we got those. And hey, this guy's got to be there. And that guy by itself does too. So we get the two one elements. All that work does pay off a little bit. Because this time, we actually have a couple more options. We actually have 4 subsets. And that's pretty good. And hopefully after 3 cases, you're starting to get some of those inductive gears turning in your head, and you're thinking to yourself, okay, maybe it means the next one would be 8. And I'll leave that to you guys to check, but if you do check that, you'll see that you would be right. That the 3-element set has 8 subsets. The empty set, 3-element set, each of the 3 2-element sets, first and third, first and second, second and third, for 8 options. And if we want to talk more generally, what that would look like as well. Where, after talking about that sort of thing, we get to an important result, a big one, this, which says that in general, the number of subsets, the number of possible subsets for a set with n elements is 2n plus 2 raised to the power n, excuse me. While if we want to talk about proper subsets, that is, this guy doesn't count, that guy doesn't count, and that guy doesn't count, it would be 2n to the power n, specific minus 1.